So now, after having worked through some pretty intense word problems, we're going to get back to the abstract and just go back to talking about angles. And we're going to consider angles in standard position is something we have to get very comfortable with for the remainder of this course. So before we move into that idea, though, let's just recall the idea of quadrants in a rectangular coordinate system. I've started to write on graph paper because for a couple reasons. One, it makes it a lot easier for me to draw a straight line, but we're also going to have lots of sketches in a coordinate system, and I just like using graph paper whenever I'm plotting points in a coordinate system. So the quadrants in a rectangular coordinate system, x and y, refer to the four corners, right, determined by the two coordinate axes. The upper right-hand corner is quadrant 1. And what we want to remember about quadrant 1 is that both the x and the y coordinates are positive in quadrant 1. And the way we number these quadrants is we actually move counterclockwise. So we move to the left to this corner, we call quadrant 2. And I'm using Roman numerals here. And you really want to be comfortable with which coordinate is positive, which is negative in each quadrant. And there's nothing profound about this, right? Because if you're in quadrant 2, just pick a point in quadrant 2. If you go down to the x-axis, you hit the negative portion, so x is negative. But for any point in quadrant 2, if you go across to the y, y is positive. So x is negative, y is positive in quadrant 2. We come down to quadrant 3, which everybody likes because both coordinates are negative. And then this corner is called quadrant 4. I'll write IV. And again, it shouldn't be a mystery because if you pick a point and go up to the x-axis, the x-coordinate is positive. Pick a point, go sideways to the y-axis, the y-coordinates are negative. Okay. Now let's start talking about standard position. So start with the rectangular coordinate system, and we're going to let theta be any angle at all. We will say that theta is in standard position if the vertex of theta is at 0, 0. So the origin of the coordinate system, there's my vertex. The initial side of the angle theta has to lie along the positive x-axis. And we rotate counterclockwise to the terminal side of theta. So we always think of measuring the angle coming around this way in the counterclockwise direction. So I'm just going to draw one example here. Here's my theta. So we call this the terminal side. And this side is the initial side. Always on the positive x-axis for standard position. And of course the vertex is at the point 0, 0. So there's an angle in standard position. So you want to develop some comfort drawing angles in standard position. And where I say sketch, you don't have to measure super accurately. The quadrant position is the most important issue here. You want to make sure you end up in the right quadrant. So here's an XY coordinate system. If I want to draw 45 degrees in standard position, well, that's easy because the terminal side will just come up as a diagonal like this. Put a little arrow mark and write 45 degrees. The initial side is understood to be the positive x-axis. 90 degrees in standard position. Here's x, here's y. Of course, 90-degree angle will extend from the positive x to the positive y. 120 degrees. X and y. I know it's more than 90 degrees. And you want to think of those multiples of 90 to help you out here. So we know 90 degrees we just drew. 180 would be a straight angle extending in the negative x direction. So I'm not all the way up to 180. I'm beyond 90. Just rough sketch right here. My terminal side's going to do something like that. There's my 120-degree angle, just a rough sketch. A little bit more than 90 degrees. And what's going to be crucial for us is to always be aware of which quadrant the terminal side lies in. So here's a terminal side in quadrant 2. 225 degrees we want to draw also. And now let me see, let's see. So I think in terms of multiples of 90, so here's x and y. So 90, 180, we're more than 180. 3/4 of the way around would be 270, right? So we're not to 270, we're between 180 and 270. So I'm going to draw my terminal side like that. I know 225 degrees is going to end up looking like so. So it's not so, doesn't matter so much where you write the number, it's identifying where the terminal side is located. In this case, for 225 degrees, the terminal side is in quadrant 3.